let's continue exploring LVM. We've lost our connection here to the server, so we'll reestablish it and continue studying LVM. So we've shown you the basic components of LVM, including physical volumes, volume groups, and logical volumes. Let's show you some other things that you can do. For example, let's suppose you want to reallocate a logical volume for a different usage other than what it currently serves. For example, this particular system has logical volumes for var1 and user1. But supposing we want to reallocate var1 to something else, such as var2 or maybe opt1. That would be an opportunity for us to rename a volume, and that's another feature supported by LVM. So LVM, or rename of logical volume, can be affected as follows. In addition to LV display, VG display, and PV display, the LV set of commands include LV rename. This command is used to rename volumes, especially when reassigning volumes, such as what we're about to do. So task, rename the logical volume that we currently have defined for either var1 or user1, doesn't matter, and not the volume group, but the logical volume. We'll rename to perhaps log vol opt1, supposing we want to use this storage as new space for opt or optional programs. So back to LV rename. We first indicate the volume group name, and we can include the syntax above, followed by the old, then the new. So the volume group, as you can see from the output from DF, is vol group 001. It's the lone volume group that we have, but no need to memorize it. That's why you've got the VG display command. VG display enumerates your volume groups. So this is the name of the lone volume group. Of course, if you have multiple volume groups, you'll need to determine which volume group is responsible for the logical volume that you'd like to rename. So LV rename vol group 001. In this case, the old name of the logical volume is log vol var1, and the new name, let's say, is log vol opt1, because we're going to use it for optional storage or for programs that make use of the optional mount point. We'll Control-Shift-V to paste. And now you see that log vol var1 has been renamed, all while the system's up and running and the logical volume var1 was mounted. When we re-execute df-h, you see that the name still reflects log vol var1 as opposed to log vol opt1. When we execute LV display, you see that the logical volume display reflects the new volume name. So you may be wondering, how does that impact our ability to write to the volume? If we were to sequence 1 million to var1, would it write? It's a very good question. Let's write test2.text to var1. And there you see the I/O has been performed, and if we lsltr var1, you see test2.text. So this change takes effect within the LVM space immediately. However, it isn't affected to the user space until you remount the file system. So note, LVM is updated immediately even while volume is mounted. However, you must unmount and mount or remount the volume, and that's the logical volume, to see the changes or to realize the changes. So that means we either execute mount with the -O option or unmount and then mount the path. So let's clear screen. We'll make a directory /opt1. We'll df-h, and if we are not currently in the var1 space in any of our windows, which we don't appear to be, we'll umount var1. This is an optional way of unmounting the long device name that's currently mapped to var1. df-h reveals that it's successful, and in fact you can examine the contents of the dev mapper by just LSLing it directly, where you'll see that the new device entry is log vol opt1 as opposed to log vol var1. So with that said, let's mount at full path dev mapper vol group 001, the lone volume group, followed by log vol opt1 to /opt1. And there you see it's now mounted, which leads us to another question, and that is whether or not we can launch or mount the logical volume using the old name. Well, let's try it. We'll attempt to mount. In fact, let's umount opt1 and then attempt to mount the dev mapper var1 to its old location of var1. Notice it fails. So what this means is that by executing lv rename, the device is updated in the dev tree. However, the changes don't take effect, at least visually in user space, until you remount the logical volume. This also means we should update the etcfs tab file. So as step B, we unmount, so umount /var1 followed by mount at opt1 with the dev location. That's log vol opt1. Then we should update etcfs tab to be sure that the volume will be mounted properly when the system restarts. So let's modify etcfs tab. We'll find that var1 entry and change it to opt1. So just like that, it's very easy to effect changes. You can modify the name of the volume, and ditto for the volume group. You can also rename the volume group. Just like with LV, there are a series of VG commands, such as VG change, VG display, VG create, VG rename. There's currently one volume group, but this volume group can be renamed to some other name that's more suitable. But for our intents and purposes, we're just interested in renaming the logical volume. We can follow through to rename the physical volume or volume group at any point. In this case, we pretended that we wanted to now assign or allocate the storage for usage by opt1, a new mount point. And just like that, we can rename it. Now, of course, we didn't have to rename the logical volume in order to mount it to opt1. We just did so to be consistent and clear. Otherwise, you could just as easily have mounted log vol var1 that's associated with var1, that is, in the opt1 mount point. Not a problem whatsoever. Super. Now, let's move on. How about something as simple as removing a logical volume? So supposing we want to get rid of the mount point that's currently there. Let's take a look at what's available. We see that currently log vol user1 is mounted, and if we mount A, we'll see that also opt1 is mounted. Supposing we no longer have a use for this log vol user1, we can remove the logical volume and then reclaim the space for usage elsewhere or at another time. The LV set of tools includes a utility named LV remove. So the task is to remove log vol user1 from the logical volume pool, which means we can reclaim that storage and assign it to something else. We could even reformat it if we'd like, which would clobber the data. So we'll execute here LV remove. Again, LV comes handy with multiple tools. Just type LV, tab it out, and you'll see what's available. Change, disk scan, and this is LVM disk scan, that is, rename, remove, so on, resize, which we'll be looking at shortly. So LV remove, followed by the path, the full path to the logical volume will do the trick. That full path, we don't need to copy it, is available in the DF output. Let's extract user 1 from here. Now we're going to try to remove the volume while it's up and running so that you can see how logical volume management responds. We're going to get rid of dev mapper vol group 001 log vol user 1. Let's try it out, and it tells you can't remove it because it's actually open. It's not because we're in the directory, it's because it's mounted and it's currently being used. So the proper step, or proper preceding step, is to U-mount or unmount the volume. So U-mount wherever it's mounted, which is currently user 1, or you could indicate the full path beneath dev mapper. Let's try that out. Again, to mount and unmount, you can specify the mount point. You don't need to specify the dev tree location, which tends to be longer as it represents the physical device. So we'll U-mount user 1, and the only thing that should prevent us from being able to U-mount it is if there are one or more users connected to the directory user 1. So that said, user 1 has been unmounted. Let's try the removal process of the logical volume again, which should be in our history. And we're prompted to confirm the change. The question reads, do you really want to remove active logical volume log vol user 1? And we'll indicate yes. Shortly thereafter, log vol user 1 has been removed. Now the way to confirm whether or not it's been removed is to use LV display. So C, use LV display to confirm removal. And we'll do just that. Notice LV display returns one logical volume for opt1, which means if we attempt to remount dev mapper vol group 001 dash log vol user 1, it'll fail. So let's mount. Even mount dash A would attempt to do it since it's in the etcfs tab file. And there you see log vol user 1 does not exist. df-h doesn't work. And even if you try to force it, let's grep user 1 from etcfs tab. Let's try to force it from the command line by mounting it exactly how we see it here. Source followed by destination, and it returns a non-zero exit status indicating that it's not possible to mount a no longer available device, which means if we lsltr dev mapper, you'll see that the lone logical volume, which is tied to vol group 001, is the volume that we renamed from log vol vol1 to log vol opt1. This all means we can reclaim the storage. Now VG display tells the full storage picture. It tells us the name of the volume group and how much total size is available, 32.62 gigabytes. It also, or the LVM set of tools, LV display, will also tell us how much of the volume group is in use. So we know 32 gigabytes are available, of which we're using 10, which leaves us or provides us the freedom to create new logical volumes for other purposes. So with that said, we've removed a logical volume. The process is straightforward. Just use LV remove to get rid of it. Now how about doing some other things, such as resizing? That's always a hot topic. So let's say initially we provisioned a volume, such as log vol opt1, to be a certain size, like 10 gigabytes. But we'd like to grow it perhaps to maybe 15 gigabytes out of the total volume group size. So our next task is to resize a logical volume. And of course LVM provides utilities. So we're going to resize log vol opt1 to perhaps 20 gigabytes. The steps include the following. If possible, unmount the logical volume, if possible. But you can exercise the LV resize option even with the volume mounted by using the LV resize command, followed by uppercase L to indicate the new size of the volume. So if we resize it to 20 gigabytes, the full path to the logical volume, which is dev vol group 001. This is a required syntax, and it's logical volume opt1, followed by the volume group container, which is simply called vol group 001. The syntax can be a little tricky, but if you execute lv resize -- help, you'll see the required options, including the size, which you must tell lv resize so it knows whether to make the volume larger or smaller, as well as the source logical volume and the group to which the source logical volume belongs or is a member. So again, we currently have it mounted, opt1, but again, we told you lv resize will attempt to resize the volume, if you indicate as such, directly while the volume is mounted. Now in this case, an error is thrown because we indicated vol group 001. You may optionally execute lv resize without indicating the vol group. So let's try it again, and we'll update our notes. As we've seen, both cases work, but in this case an error is thrown when we indicate the volume group. So we'll try it without the volume group by stripping it and then setting it to 20 gigabytes. And there you see it has resized it. Now what does this all mean? Well, we should confirm the new size. So the next step is to execute lv display to confirm new size of logical volume. And once we've confirmed the size, then we'll tell you what it all means. Let's copy and paste this command. And you'll see that the lone logical volume, logvol opt1, is now 20 gigabytes as opposed to 10 gigabytes. However, is this reflected in the file system as the users see it? Well, df-h will tell us whether or not it is. As you can see, it's still about 10 gigabytes. So df-h will still reveal the current size. And that is because the file system that was allocated to the original logvol opt1 was allocated for only 10 gigabytes. So in other words, inodes were calculated for only 9.910 gigabytes. We now need to resize the file system to take into account the new raw storage. So in this case, we need to resize the file system to update the inode table on the logical volume to account for the new storage in the logical volume, or in logvol opt1. And there's a utility for just that purpose. And that is resize 2fs. It's used to resize ext2 as well as ext3 file systems. It supports many options. Let's navigate to the shell and execute resize 2fs. In fact, if you just type resize and tab it out, you'll see that it's one of the 3 available commands. Some useful options include -f to force the resize, as well as -p to print the status. And a required option is the device that you intend to resize. Whether you're shrinking or growing an ext2 or 3 file system, you'll use resize 2fs. Now generally you should unmount the volume so that no files are clobbered and errors aren't generated, so that resize 2fs has exclusive access. However, with a 2.6 series of the kernel, the Linux kernel, you can attempt to resize while the file system is online for those really busy systems that cannot be taken offline. So let's outline our commands. Resize 2fs, we want to force plus print the options for dev, and we'll just copy the location to the device from above, and then paste this at the command line. Let's go ahead and reset the buffer. Again, it's currently mounted, opt1 that is, and we're going to attempt to resize it. Now it tells us the file system is mounted at opt1, an online resizing required, performing an online resize of the volume. It's also usually faster when you resize offline. Now with that said, let's echo the exit status. It's good. We'll df-h, and notice online while users were connected, presumably, we were able to resize the file system from 10 gigabytes, which is what we saw earlier, to 20 gigabytes. Again, this works currently only with ext3 file systems. Note, you may resize file systems online if the following are met. 1, you're running a 2.6 kernel series. It will indicate 2.6x kernel series, which we are, since it's Red Hat Enterprise 5. But if you're running SUSE 10, Ubuntu, or Debian 4X, you'll also run or be running 2.6x of the kernel. And 2, the file system must be formatted with ext3 as opposed to ext2. So this will help you when defining partitions for production systems. Go with ext3 or RiserFS wherever possible, as those file systems can be resized. ext3 can be resized using the Resize2FS program, which is auto-installed while online, and there you see it. It's now 20 gigs. Now how about shrinking the file system? Well, it's all a part of resizing, of course. So the first task is to grow, which also means to resize. And our second task is to shrink, which also means to resize. Logical volume opt1. This is a very neat feature. Let's say we want to send it now to, or reduce it to 15 gigabytes to make space for some other mount point. Very, very useful feature, especially for busy production systems. So again, LV resize, and the new size will be 15 GB as opposed to 20 GB. For the full path, dev vol group 001, logical volume opt1. That's the volume that we're using at this particular point. We'll confirm with LV display that the logical volume is indeed 15 gigabytes. We'll use df-h to confirm what the user space reflects. The user space will reflect the old information, but Resize2FS will ensure that that information gets updated. Step D or 4 is to resize using Resize2FS with the force option, which is not always required, but we turn it on anyway in the event that there are problems, for the full mount point of dev vol group 001 log vol opt1. And then, once that's finished, confirm again with df-h. So let's walk through these steps to shrink the file system. And it's always a good idea to shrink the file system before too much I/O occurs or within acceptable or predictable parameters. For example, if you've allocated 20 gigabytes and your users have consumed 17 to 18 gigabytes, then you cannot shrink to 15 gigabytes without losing data. So be careful when shrinking. Expanding is usually easy, and we should note that as well. Note, check utilization, and that's of course disk utilization, prior to shrinking to reduce the risk of losing data. However, when you grow a file system, that risk is not as prominent. So, currently, what's in use on this volume? 169 megabytes of 20 gigabytes, which means if we reduce to 15 gigabytes, we'll lose nothing. So with that said, with the exception of the 5 empty gigs, of course, let's execute LV resize 15 gigabytes. And this tells you, reducing it can destroy data. We know certainly that it will not impact us. And now, when we execute LV display as our next step, you'll see that the logical volume has been restored to 15 gigabytes. The next step, df-h to get a sense for what the file system thinks the mount point is. It currently thinks it's 20 gigabytes, so it's going to proceed with writes or IOs under the assumption that the file system can hold 20 gigabytes, which is why we need to execute resize2fs on the ext3 file system to bring it down to size. And this tells you online shrinking from one size to another size is not supported. If we df-h, you see that it's still 20 gigabytes. Well, what does online shrinking mean? It means you need to unmount, or not supported means you need to unmount the file system. So we should just note online shrinking is not supported. Now, of course, this may change, but it currently is not. So we should unmount the file system. Let's umount opt1 and give that another shot, resize2fs. And here it says it can't read a block bitmap while trying to resize. Sometimes it throws errors. df-h, it's still unmounted. And although it's throwing an error, we're going to try to remount it to see if it's taken. And if it doesn't take, this is an opportunity for you to reboot the system to single user mode to attempt to resize it, to shrink it. So sometimes there are problems like this, attempting to shrink the file system, at which point, if you have the luxury, you'll reboot the system to single user mode, make the changes, then return to multi-user mode. Let's try to mount it again. We'll mount del vol group log vol opt1 to opt1, df-h, and there you see it took it as 15 gigabytes. So again, sometimes it throws errors, and sometimes it won't work, which is a signal that you need to enter run level number 1 to make the change. However, growing the file system tends to be straightforward. The resize2fs excels and works well in that environment. Sometimes it throws errors when shrinking, especially if you've experienced any amount of I/O to the file system while it was up and running. Now there is a GUI utility available, the systemconfig LVM utility. LVM GUI tool. And it is known as systemconfig LVM. Let's give this a shot, although it's on a remote system. And here it throws an error, so what we'll do is we'll SSH into the system with X, redirection back to our local system using uppercase X. Then try that again. This will bring up the utility on our local system. This tool will allow you to interact with your logical volumes within a Red Hat environment. We'll just make sure it's maximized, and here we see the volume group 001. We see a logical view, which includes log vol opt1, which is using roughly 40% of the total space of the volume group. We see a volume group perspective, which includes the physical disks, SDC3, SDB3, and SDA3. These items allow you to click to zero in on them so you get a sense for where the storage is allocated. For example, logical volume opt1 is tied to the following storage. 3578 extents belong to SDC3, or the third SCSI disk. A fraction of those extents are mapped to SDA3. So in fact, when you make use of log vol opt1, eventually you will write some of the data to SDA3 as well as SDC3, so you'll end up with data in both places. You can hover over a volume group and the individual items. You can do things to the volume group below, for example, like extend as well as remove. Extending a volume group allows you to add storage to it to make it bigger. You can focus in on the individual disks that are members of the volume group, and you can zero in on the specific partition. For example, SDA3. You can remove this volume from the volume group, but be careful when removing volumes because you could end up rendering data lost. So this interface allows you to interact with the volume groups. You can initialize a block device, and again, from the top level down, add items, remove items, create new volume groups, extend or remove a selected drive from the volume group. And you can also focus in at a lower level from the logical view level, which beneath volume group 001, currently there's only one volume. If you want to create a new volume, let's say for user 1, for example, like we had earlier, go ahead and name it logvol user 1. It doesn't have to be named this, but this just works for our situation to be consistent with what we have named logvol opt1. So logvol user 1, you can determine if it's striped or mirrored. Those are two other forms supported by LVM. The default is linear, where it writes to the first accessible physical extents and then maps it out as necessary on other drives that are members of the logical volume and of course tied to the volume group. But you could stripe to take advantage of performance increases by mapping your logical extents across multiple physical extents simultaneously, benefiting from faster I/O. You can determine the size of the logical volume in extents or in megabytes or gigabytes. So if we wanted user 1, for example, to be the full space, 17.61 gigabytes, we could stretch it to the full size or indicate manually something like 5 gigabytes, which is the equivalent of indicating dash uppercase L space 5 GB. You can determine if you want a file system associated with it, whether or not to mount it to a place such as user 1, and also whether or not you want to mount when it's rebooted. These are all the things we've been doing manually via etcfs tab and mount and umount from the command line. All of this can be addressed from this interface when creating a new logical volume. And again, you can determine if it's striped, how many stripes, the kilobytes of the stripe, so on and so forth. It tells you must have enough free space on physical volumes to enable mirroring. So with that said, let's proceed. We'll click on OK. All of the commands are now being kicked off in the background. The ext3 file system is being overlaid, and momentarily you will see the new logical volume, logvol user 1, allocated. And there it is, logvol user 1. And it's also mounted. Beneath the volume group view, we'll see both logical volumes. And if we close this utility after having used it to create the item for us and navigate to the shell, you will see when we execute df-h that the logical volume has been mounted for us. We could then rerun the utility and extend the size of the volume, and the GUI will take care of issuing the appropriate commands for us from the shell. So use system-config-lvm to do some of the steps that we've shown you manually. However, it's always important to know which commands are applicable from the command line, and we've shown you thus far the various PV, VG, and LV based commands that are important for creating and resizing volumes. Now we'll be discussing other things you can do with file systems such as RAID momentarily.